Assalamu alaikum everyone. I am Nommathex. Welcome to my YouTube channel. So if you like this video, please share it with your friends and subscribe to my YouTube channel. Watch this video to know the different aspect of differentiability of a function. Differentiability of a function at a point. So in this video, I am trying to explain when we say a function is differentiable at point P. Next we will learn when we say a function is differentiable function, and next we will learn what is derivative of a function. This concept is little difficult to understand, so please watch this video till the end. A function f of x is differentiable at P if and only if there exists a unique tangent to the curve f of x at P. And throughout this class, I am going to discuss on this point only when function is differentiable at P. So there exists a unique tangent to the curve at point P. So conversely, if there exists a unique tangent to the curve at point P, then f of x is differentiable function. So this is if and only if condition. Now consider a coordinate axis, O is the origin, and take the curve y is equal to f of x. So draw a line. You observe this line. This line cuts the curve at 2 points. Name them P and Q. Now what is this line PQ? This line PQ is called the secant line PQ. So this line cuts the curve at 2 points. So this line is called secant line PQ. Now observe the diagram. What is the point P? So P is the point we suppose which is at a distance of x units from the origin. So P is the point which is at a distance of x unit from y-axis. Now what is this length? This is height of the curve. So what is this length? This is f of x. So what is the point P? So it will be x comma f of x. Now where the point Q? Observe, if we move towards right from the point P, which is at a distance of h units. But remember, this h is very small positive quantity. So what I am trying to say, so Q is the point which is at a distance of x plus h units from the origin. Observe the point Q. Q is at a distance of x plus h units from y-axis. So this length is x plus h. Now what is this length? This is height of the curve. So this length is f of x plus h. So what is the point Q? Q is x plus h comma f of x plus h. Now observe, as Q is approaching to P from right. So what happens? The secant line, you think. Observe the diagram please. See the secant line PQ. Observe the tendency of secant line PQ. When Q approaches to P from right, observe the secant line PQ. It is moving. Please observe the diagram. The secant line PQ. As Q approaches to P from right, the secant line PQ is becoming tangent to the curve at point P. Please observe this carefully. When Q approaches to P from right, the secant line PQ is became the tangent to the curve y is equal to f of x at the point P. Understand this, when Q approaches to P from right, the secant line PQ is became tangent to the curve y is equal to f of x at point P. That's mean when Q approaches to P from right, observe here, x plus h is approaches to what? So x plus h is approaching to x. When Q approaches to P from right, x plus h is approaching to x. When x plus h is approaching to x means h is approaching to 0. Now observe the diagram. Take another point R on this curve. Now you can see the secant line PR. Observe towards the left of it. R is at a distance of h units, the left. Now what is R? R is at a distance of x minus h units from the origin. So this length is x minus h. Now what is this length? The length is f of x minus h. So from the diagram, it can be understood easily. So r will be x minus h comma f of x minus h. So when r approaching to p from left, please observe r is approaching to p from left. Now observe the secant line PR. Observe the tendency of the secant line PR. Now observe the tendency of the secant line PR. It is becoming tangent to the curve y is equal to f of x at the point P. So what we observe here, when Q approaches to P from right, R approaching to P from left, the secant line is became tangent to the curve y is equal to f of x at point P. That's mean we observe that for this curve y equal to f of x, there exists a unique tangent to the curve at point P. Observe here, x minus h is approaching to x. It means when r approaching to p from left, so x minus h is approaching to x. It means that minus h is approaching to 0. It is nothing but h is approaching to 0. So I will conclude, when we say a function f of x is differentiable at a point P, if there exists a unique tangent to the curve y is equal to f of x at point P. I hope you understand this class. If you like this video, please press the like button below. Share this video with your friends.